Okay, in this video I just want to do an example of finding higher order partial derivatives. And the first thing I want to talk about is just understanding the notation. So suppose we have a function of two variables. The one I'm going to do is two variables, x and y. And we want to understand what the notation, this little f of x, y, x of xy, what does that mean to do? So just one particular example. Sometimes they won't even write the xy at the end. In the parentheses, they may just say calculate, f of x, y, x. So in this example, suppose we have the function 9e to the 2xy, and we want to find f of xy x of xy. So all this means to do, it's basically just telling you an order in which you have to do partial derivatives. And so basically, if you look at the first letter, we see an x. So all that means to do is to first take the derivative with respect to x. So with respect to x, and that'll produce a new function, well, the partial derivative of f with respect to x. After that, it says, well, then you have to take the derivative, so you take the derivative of the new function that we just found, f of x, only we do it with respect to the letter y, the variable y. And then it says, okay, we'll do x again. So now it says take the derivative, and I should say in step 2 this produces your new function, f of xy. And then it says take the derivative of that with respect to x. So again, it basically says take partials with respect to x, then with respect to y, then with respect to x again. So sometimes you may have to do, x, 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 y, y, y. The problem could say anything, but all it really tells you is an order in which you need to do things. So let's do this example here. So we've got our function. We want to calculate this f of xyx. So the first thing we'll have to do is find the partial derivative with respect to x. And if we take the derivative with respect to x of this function, so the derivative of e to anything, you get, well, the exponential right back. Then you have to take the derivative of the exponent. Since I'm taking the derivative with respect to x, I treat x like a variable and the 2y like a constant. So I'll simply be left with this extra bit, this 2y. So if I simplify this down, 9 and 2 is 18. I think I'll write the y part next. And then I have e to the 2xy. So that's my first partial derivative with respect to x. So now the second thing I'm going to have to do is take the derivative of this new thing, only I'm going to do it with respect to y. Well, to take the derivative with respect to y, now I'm going to have to use the product rule on the function I just found because I have a product of y's. So if I take, maybe I'll kind of group the 18y as one part and the e to the 2xy as the other part. Okay, so if I take the derivative of the 18y, I'll simply get 18. I'll leave the e to the 2xy alone, plus now we'll leave the 18y portion alone. And if I take the derivative of e to the 2xy, again I'll get, well, e to the 2xy. Again, though, now I have to remember I'm taking the derivative with respect to y, so I treat y like my variable. The 2x is just a constant. So when I take the derivative of the exponent, I'll simply be left with a 2x. Okay. So maybe let's clean this up again just a little bit. So I don't see a lot to do here on the first term, so I'm just going to leave him alone. Let's see, we've got 18 and 2. That looks like 36 to me. We've got an x and a y. I like to alphabetize just to keep things kind of consistent. And then I have my e to the 2xy. Okay, so we're almost there now. We've got to take yet one more partial derivative. And this time, to finish it off, I'm going to have to take the partial derivative of this new function we just found, Only this time, though, we'll have to do it with respect to x. Okay, so let me jot it up here at the top real quick. So we just found that it was 18 e to the 2xy plus 36 xy e to the 2xy. Okay, so last but not least, we'll take the derivative of this now with respect to x. Okay, so on my first term, the 18 just gets carried along. Again, we saw that the derivative of e to the 2xy is going to be, well, e to the 2xy. Again, I'm taking the derivative with respect to x. That's my variable. 2y is a constant, so that'll just get dropped down. It looks again like I'm going to have to use the chain rule on the second part, excuse me, the product rule along with the chain rule on the second part. So I'm going to group the 36xy as one term, and I think I'm going to give myself a little extra room because I know I'm going to run out. So if I take the derivative of the 36xy, again I'm doing it with respect to x, I'll just get 36y. I'll have to leave the e to the 2xy portion alone. Product rule has a plus. I'll leave the 36xy portion alone. I'll have to take the derivative of e to the 2xy. Well, I'll get e to the 2xy, and again the derivative of the exponent with respect to x will simply be 2y. Okay, so let's see if we can't condense this a little bit. It looks like we've got 18 and 2, that's 36y e to the 2xy. It doesn't look like there's much of anything to do on my second term. So we've got 36y e to the 2xy. And it looks like on the last part I've got 36 and 2, which is 72. I've got an x, I've got a y and a y, so that's y squared. And then I have my e to the 2xy left over. Hey, it looks like we've got like terms here. I've got a 36y e to the 2xy and a 36y e to the 2xy, so we can simply add those together. 36 and 36 would be 72y e to the 2xy. And at this point, I think I would probably call it a day. You know, you could certainly factor out some stuff. You could certainly factor this if you needed to. You could pull out the 72. You could pull out the y. You could pull out the e to the 2xy. But you know, if it just said take, you know, find the third partial derivative here, I think that's where I would stop. So, all right. I hope this example makes some sense. If you have any questions or comments, let me know. And as always, feel free to ask questions. All right, thanks out there.